Hello everyone. Okay, so today we are looking at compound interests. Right. So what is compounded interest? So what interest is, if you put money into a bank or a savings account, they will give you a percentage of that money you've saved every year. So say for example, you are with a bank, you have €500 in a savings account. Now they're going to say, we're going to give you an interest of 20% every year. Now this is very unrealistic, but for the sake of simple mathematics, we're just going to say it's 20%. So you're going to get 500, you're going to get interest of 20% of that 500 every year. So year one, in your saving account now, you are going to have €500 plus 20% of that €500, which is 100. So at the end of year one, you're going to have now €600 in your bank account. So year two, you're now going to have €600 in that bank account, and now you're getting €600, 20% of €600. And then 600, so you're going to have 600 plus €120 interest. And at the end of the year, you're going to have €720 in your bank account, and so on and so forth. So that's how it works. So there is a special formula, so I'm going to show you how we derive it now in a moment. So I'm going to say F is my final amount. So F is the amount I'm going to be left with at the end of a certain time period. So how do I find that? Well, let's just look at year one here. So year one here, what's happening here? The 500 plus the 500 times 20%. Well, I have my principal amount, and what's happening is I am increasing that by 20%. Now, another way of doing this is using multipliers, which we learned about previously. So it's going to be 500 times 1.2. All right, because 0.2 is the same as 20%. Let's look at year two. So year two, the amount I'm left with at the end of year two is going to be my amount from the previous year, which is 500 times 1.2. Then times 1.2 again, because I'm increasing it again by the interest rate. That same goes for year three, right? My amount is going to be the previous amount. Again, increase 20%. So we're starting to notice a pattern here, right? So if I go down to year N, right, and I generalize it, I'm going to have 500 times 1.2 times 1.2 times 1.2 times 1.2. This is going to happen N amount of times. So if I have multiplication, if I have a repeated multiplication of the same thing, so in this case I have 1.2 times 1.2 times 1.2 times 1.2, I can say that's going to be 500 times 1.2 to the power of n, right? Where n is the number of years. So let's now apply this more generally to this case. So I have a final amount of money. I'm trying to find the amount of money I'm going to have at the end of a certain year period. So this is year one. So I have a certain amount P. This is going to be known as my principal value, right? So this is my final value. This is my principal value. Now, I want to multiply this by 1 plus I, where I is my interest rate in decimal. So I is my interest rate in decimal. You probably, I don't think you see the yellow. Let me just fix it. Boom. The purple. So I is my interest rate in decimal. And that makes sense because previously here, right, my interest rate was 20%, and 20% is equal to 0.2, and 1 plus 0.2 is equal to 1.2. So that makes sense over here. So that's the end of year one. This is my value I have at the end of year one. And again, the same goes here. Year two, my final amount is going to be equal to the previous amount times my increasing by my interest rate again. Year three, it's going to be my previous amount here. 1 plus I times 1 plus I. Again, increased by my interest amount, which is 1 plus I. So if I was to keep this going until year T, right? So this could be, you know, year 20, 30, 40, 50, 60, 80, 90, 100. So year T, so we're generalizing this now. F is equal to P times 1 plus I times 1 plus I times 1 plus I. That's going to happen T times. And again, if I have repeated multiplication, that is the same as indices. So I'm using my indice rule here. So 1 plus I to the power of T. And that is my compound interest formula. So I derived it there. Let's go back into my main page here. So there's my formula there. It's in your log table book. So F is equal to P, 1 plus I all to the power of T, where F is my final amount, P is my principal amount, or my starting. Even got my starting amount, guys. It's my starting amount. I is my interest rate in decimal, and then T is time, and it's usually in years. So let's have a look at an example here. Calculate the value of $5,000 invested at 2.5% per annum. Per annum will for 4 years. Per annum will. Okay, sure, why not? Right? So, my final amount, I don't know what it is, so it's going to be F. My principal amount, what did I start with? Well, I started with the $5,000. I is going to be equal to, so we need to write 2.5 as a decimal. So what we can do here is just divide 2.5 by 100. So I'm going to have 0.025. And then T, my time, is going to be equal to 4. So let's just sub it into my formula. So F is equal to P times 1 plus I all to the power of T. So F is equal to 5,000 times 1 plus 0.025 all to the power of 4. Sub that in. So 5,000 times 1 plus 0.025 all to the power of 4. I'm going to have now, at the end of the 4 years, I'm going to have 5,519 euro and 6 cents, or dollars, whatever it was. So my interest earned in this case, my interest earned was $519.06. That was my interest earned. So that's how much money I got for investing that €5,000. Now, it doesn't seem like a lot. You probably could have more smartly invested that €5,000 if you would have got 500 back after 4 years. But sure, look, you know, free money, girls, and we're not gonna turn our nose up at free money. No one is too good for free money. Right, so let's look at this question here now. So a company now has invested $25,000 for 3 years at a fixed rate of compound interest. At the end of the 3 years, it amounted to 27,340.20. Sorry, that's a mistake there. So 27,340 euro and 20 cents. So find the rate of interest. So I have here my final amount is $27,340.20. My principal amount, what I started with $25,000. My interest rate, I don't know what my interest rate is, and it says here I invested for 3 years. So let's sub it into my formula. So F is equal to P times 1 plus I all to the power of t. So my final amount is $27,340 equals $25,000 times 1 plus I, because I don't know what I is, all to the power of 3. So now, this is just a case of rearranging to get I on its own. So I have this 25,000 over my bracket, so I'm going to divide both sides by 25,000. So that will get rid of my 25,000 here. Now, what else do I have to deal with? Well, I have this little 3 on top here. So I need to get rid of my indicator, this power. So what's the opposite of cubing a number? Well, it's going to be cube rooting a number. So a cubed root is very much like a square root. But it's just a case of what number do I multiply by itself 3 times to get the value. So you can use your calculator here to find the cubed root of something. So here's my calculator here. Let me just move over here. So in your Casio calculator anyway, there is a cubed root button above my square root button here. If you click shift, so if you click shift and then this, you will get your cubed root. But what if it's a case of it's like 4 years, 5 years, 6 years? So what you need to do is you need to click shift and then you need to click this X to the power button here. And now it will give you a blinking box outside of my root line. So I'm going to put 3 here. And then in my bracket, I'm going to put the €27,340.20 all over 25,000. Click equals. So I'm going to have 1.0302 is equal to, let me get rid of my calculator here. So I'm cube rooting something that's cubed. They're going to cancel out. So 1.0302 is going to be equal to 1 plus I. Therefore, I is going to be equal to 0.0302, which is, if we want to find the actual percentage, %3.02%. So, and this company was earning 3.02% on their investments over the 3 years. So that's how it could be applied there. So let's look at some more exam type questions. So this is from the 2020 sample paper. So Miley has 3,000 euros in a special savings account. It has an interest rate of 2.5% per year for 4 years, compounded annually. So that is my key word here, compounded annually. So I'm going to be using my compounded interest formula. She does not put any money or take any money out of this account over the 4 years. Work out the total amount in the account after the 4 years. Give your answer correct to the nearest cent. So F equals, well, I'm trying to find out how much she has at the end of the 4 years. So it's going to be F. Principal amount or starting amount. Well, her starting amount is the €3,000. Her interest rate is 2.5%, which is equal to 0.025. Remember, we need to write a decimal. And then T is equal to time, which is 4 years. So we just need to sub it into our formula. F is equal to P times 1 plus I to the power of T. F is equal to 3,000 times 1 plus 0.025 all to the power of 4. So 3,000 times 1 plus being 0.025 all to the power of 3. You put that in your calculator, you'll get F is equal to €3,230 and 67 cents rounded. So her final amount after the 4 years is €3,230 and 67 cents. So these questions are very straightforward. Right, here's another one from the 2015 sample paper paper 1, question 4, when junior cycle maths used to have 2 papers. So Dermot has €5,000 and would like to invest it for 2 years. A special savings account is offering a rate of 3% for the first year and a higher rate for the second year if the money is retained in the account. Tax of 41% will be deducted each year from the interest earned. So A, how much will the investment be worth at the end of the year 1 after tax is deducted? So if you notice here, we are earning interest, but it's not compounded interest because our interest rate is changing every year. So let's fill out my formula here. So F is equal to, well, I'm looking for my final amount. P, my principal amount, well, it's €5,000 because it says in the question here. German has €5,000. It's invested for it's invested at 3%, so 0.03. And he wants to find out at the end of the first year. So T is just going to equal 1 year. So let's find out. So F is equal to 5,000 times 1 plus 0.03 to the power of 1. Put that in your calculator. And we should get the final amount to equal €5,150. But there's a little caveat. There's a caveat, ladies and gentlemen. Tax of 41% will be deducted each year from the interest earned. So from the interest earned. So the bank isn't taking away 41% tax on the entire thing. It's only taken away on the interest. So we need to account for that. So the interest earned, I'm just going to call that IE, interest earned, is €150. So I need to minus 41% from that. So let me go open my handy dandy calculator here. So I need to first find 41% of €150. So €150, and I want to find 41%. So remember, it's a trick we can do on a Casio calculator. Multiply 4, 1. Now I need to get my percentage symbol. So I need to multiply by the percentage I'm finding. So it's going to be shift answer. And now I have 150 times 41% equals €61.5. So interest after tax, it's going to be 150 minus my 61.5, which is going to be, oh sorry, let me go in my calculator here. So 150 minus 61.5 equals €88.5. So therefore, her final amount after year 1, after 1 year I should say, is going to be her initial amount plus the 88.5. So it'll be €5,088, €5,088.50. So that is how much she will be earning after tax is deducted from her interest earned. Right, let's look at part B. So Dermot calculates that after tax has been deducted, his investment will be worth €5,000, €223.60 at the end of the second year. Calculate the rate of interest for the second year. Give your answer as a percentage. So, this is after his tax has been deducted. Yeah? So, let's have a look at how much interest has been earned here. Because, so my principal amount here is €5,000.88. It's €5,088.50. So this is what he started with, right? So start of year 2. Year 2. He had €5,000 and €5,088.50. Now at the end of year 2, he has €5,223.60. So let's first calculate the interest, right? Let's see and find out how much he gained from that now. So he earned so 5,223 euro 60 cents minus 8850. So he earned 5223.6 minus 5088.50. So he earned 135 euro and 10 cents. So this is his interest after tax. So this is his interest after tax. Now remember, the tax is 41%. So I know for a fact, I'm going to say X is the OG interest. Yeah. X is the OG interest. So 135 euro. Yeah. That's going to equal to my original interest earned. And I'm going to minus 41% of my interest earned. So 41% of my X. That's going to equal X minus, change this 41% to a decimal, 0.41X. So I have 135 euro and 10 cents is equal to 0.59X. So this interest earned is 59% of the original interest earned. So we're going to find how much interest he earned in the second year. So divide both sides by 0.59. So 228 euro and 98 cents. That was his original interest earned. So interest before tax. So if we add this now to our year ending or a year starting value. So if we add this, let me do a different color. So if we add 228.98 to 5,088.50, that is going to give me the amount that his investment has earned before that tax was applied. So if you add them together, so at the end of year two, he has earned his investment is worth 5,317.483. Where does it say 48 here? So that is my final amount. My principal amount is going to be the 5,088 euro. That's what we started with in the second year. My interest is just going to be I, because I don't know what it is. And then time is going to be 1. So 5,317.48 is going to be equal to 5,088.50 times 1 plus I to the power of 1. So I'm going to divide both sides by 5,088.50. So I'm going to have 1.045 is equal to 1 plus I. Therefore, I is going to equal to 0.045, which is going to be 4.5%. So the interest on the second year is 4.5%. And this kind of makes sense because it tells us here he is getting a higher rate at the end of the second year. It says here, so the higher rate for the second year, and if his initial rate was 3% and we got 4.5%, so that is a higher percent there. So that was a difficult question. That was from the pre-junior cycle paper, so it would be a bit harder, more in depth, but it's good to see these types of questions. And yeah, so that's me done. I'll catch you on the flip side. Hope with some help. Bye.